check. Hi, Moni Saran. Check. நல்லா கேக்குது. சூப்பர். Still என் ஆடியோவும் ஸ்க்ரீனும் நல்லா கிளியரா தெரியுதா? ஆடியோ நல்லா கேக்குதா? Yeah, just let me know in the chat, guys. Come on. Hi, Safura. It's been so long போல ரொம்ப நாள் ஆச்சு கிளாஸ் எடுத்து. Yeah. Yes, bro. Okay. Fine. All right. Guys, you கொஞ்ச நேரம் பேசலாம். Audible. Thank you. As usual, class for the first 10-15 minutes because கடைசியில் பேச முடியாது. I extend the class and this chapter is also கொஞ்சம் பெருசு. So yeah, இப்போவே கேட்டுலாம். So whatever you have, any doubts உங்கள் ப்ரிப்பரேஷன் பற்றி, yes, I'll try to help you as a mentor, a brother, a senior. Okay. இனி எவ்வளோ நாள் இருக்கு எக்ஸாமுக்கு? அண்ணா, how are you? முரளி, நல்லா இருக்கேன்ப்பா. அண்ணா, எஸ்என்ஜி ஆப் பற்றி ஃபுல் டீட்டெயில்ஸ் சொல்லுங்கள், எங்களுக்கு யூஸ்ஃபுல்லாக இருக்கும். ஓகே. எஸ்என்ஜி ஆப் பற்றி ஓகே. I'll open the app and show you 1 minute. லோட் ஆகிட்டு இருக்கு. இந்த ஐபேடில் இருக்குமா? Okay, I have to log in with my account. Okay, again. So yeah. So you guys still don't know. Okay, final days before NEET, what would you suggest for biology, prioritizing NCERT revision or question solving? Biology, I would suggest you to stick with NCERT. Question solving, actually ரெண்டுமே பண்ணணும். ஓகே, when நீங்கள் கொஷின் சால்வ் பண்ண you will get to know which one where you are lacking-லாம், எந்த லைன்லாம் சின்ன மிஸ்டேக் பண்ணுறீங்களோ உங்களுக்கு அப்போ தெரியும். ஸோ ரெண்டுமே இருக்கணும். ஸோ யூ சால்வ் கொஷின்ஸ், and then you do mistakes and then rectify it by studying NCERT. ஓகே, ரொம்ப லேட் கடைசி எண்டு ஒரு 1 வீக்கெல்லாம் போகும்போது நான் ஐ கேவ் அப் ஆன் சால்விங் எம்சிக்யூஸ். ஐ ஜஸ்ட் ரெட் தி NCERT அகெயின் அண்ட் அகெயின் எவ்வளோ முடியுதோ. எஸ்என்ஜி ஆப்பில் ஓகே, பேசிக்கலி I don't think it will be visible in my phone. காமிச்சா உள்ளே போனோடனே தெரியுதா? ஒரே நிமிஷம். தெரியுதா? Yeah, so உள்ளே போனோடனே you'll have over a daily quiz. Okay, I mean you'll have MCQs. So okay, every day there. அதுக்கப்புறம் இந்த ஆப்பில் வந்து you'll have daily worksheets மாதிரி இருக்கும். And you'll have chapter wise questions, okay, for every single chapter in NEET 20, which will be asked in NEET 2026, including the extra syllabus. Okay, NCERT syllabus. Physics I took question papers, so every chapter in around 24 chapters நினைக்கிறேன். எல்லா சாப்டருக்கும் 45 questions are available in the app. If you want, go check it out. And then you're having unit test. Physicsல வந்து 11th வந்து entire 11th ரெண்டு டெஸ்ட் ஆகும், entire 12th ரெண்டு டெஸ்ட் ஆகும். நான் பேப்பர் எடுத்திருக்கேன். அதுக்கப்புறம் அது முடிச்சதுக்கப்புறம் you're having grand test, full syllabus tests on the entire syllabus. Okay, 45 questions for one paper. Obviously அது it includes everything. Okay, I took நல்ல ஸ்டாண்டர்டான கொஸ்டின் தான் எடுத்திருக்கேன். If you want, go check it out. Yeah, so now please teach how to solve numericals. I still don't know. Numerical solving comes with practice. Okay, there are a lot to this, not just in NEET. Basically, when you're writing exam, you know concept which there is formulas. Okay, formula apply பண்ணோம். Okay, all these three should be there. Along with that, you should manage your time. Okay, so if சில பேர் வந்து before before examination they'll be able to solve questions proper, and then when they are in the examination, time constraint their mind won't work. Okay, that requires practice. Okay, this entire exam is constructed over this thing that time வந்து ரொம்ப கம்மியாக இருந்து time constraint ஓட தான் வந்து அதனால தான் it's difficult. Okay, even though the questions were simple, still people used to make mistakes because of the time constraint thing. Okay, so அதை வந்து with practice தான் you can improve it. Okay, final days before NEET, I told this. Yeah, ஆனால் எனக்கு இப்போ தான் எக்ஸாம் முடிஞ்சு, எனக்கு ஒரு 40 day plan சொல்லுங்க. See, I could tell you a plan. Okay, I could give you a structured plan of everything, but it won't be personalized to you. உனக்கு வந்து உன்னோட ஸ்ட்ரென்த்ஸ் எது, உன்னோட வீக்னஸஸ் எதுன்ட்டு only you know. எனக்கு தெரியாது. Okay, so I can't make you a proper plan, but still if you tell me where all you're strong and where all you're weak, I could give you an ஒரு ஸ்கெலிட்டன் மாதிரி கொடுக்கலாம். இதில் வந்து யூ ஜஸ்ட் ஃபில் வாட் எவர் யூ வாண்ட். அப்பப்போ மை ஒப்பீனியன் இஸ் நாட் ஸ்டடிங் ரேதர் தென் ப்ராக்டிஸிங் ஃபுல் சிலபஸ் டெஸ்ட் இப்போ இருந்தே. ஓகே, இட்ஸ் ஆல்மோஸ்ட் ஏப்ரல். ஓகே, ஃபுல் ஆன் சிலபஸ் டெஸ்ட் நான் பேசிக்காக சொல்லுங்கள். யா, அதான் சி ஃபுல் சிலபஸ் டெஸ்ட். ஓகே, எவ்ரிடே 1 or 2 3 hours டைமர் வச்சு யூ சால்வ். ஓகே, சால்வ் பண்ணதுக்கப்புறம் ரெக்டிஃபை யுவர் மிஸ்டேக்ஸ், அண்ட் மிஸ்டேக்ஸை ரெக்டிஃபை பண்ணதுக்கப்புறம் ரிவைஸ் இட் பிஃபோர் அட்டெண்டிங் தி நெக்ஸ்ட் எக்ஸாம் தி நெக்ஸ்ட் டே. ஓகே, யூ கீப் ஆன் ரிவைசிங். அப்பப்போ ஐ மேட் திஸ் மிஸ்டேக். என்னென்ன மிஸ்டேக்ஸில் வந்து எதெல்லாம் வரும்னா, த திங்ஸ் which you didn't attempt as well. Okay, and also the things which you, also the questions which you fluke answer correct போடுறது, everything comes under mistakes தான். Okay, because you don't know the correct answer, you don't know how you got it as well. Okay, so அதெல்லாமே you must rectify it. Okay, you must have clear idea about whatever they are. அவ்வளோதான். ஸோ 30 daysக்கு 30 full syllabus test. ஃபிசிக்ஸில் என்னென்னா சாப்டர் படிக்கணும். எஸ்என்ஜி ஆப் ஸ்வர்ணா SNG app full details சொல்லுங்க ப்ளீஸ். ஓகே, see, basically you have MCQs. நீட்டுக்கு you know the entire exam is constructed over MCQs now. This app has MCQs for every chapter, and I took for physics எல்லா சாப்டருக்கும் 45 questions which covers the entire chapter. எல்லா டாபிக்ல இருந்தும் questions வர மாதிரி I took. So is for chemistry and bio as well. And then and the 45 questions for every chapter தாண்டி you're having 2 sets of question papers for both 11th and 12th. So 11th ரெண்டு பேப்பர், 12th ரெண்டு பேப்பர். 11th ரெண்டு பேப்பர் வந்து ஒரு பார்ட் 11th ரெண்டாக பிரித்து ஒரு பேப்பர்லேயும் இன்னொரு பார்ட் வந்து இன்னொரு பேப்பர்லேயும் இருக்கும். அதே சேம் அப்ளைஸ் ஃபார் 12th as well. So 4 unit test papers and then 15 full syllabus tests which contains all the chapters. Okay, again I took physics அதுக்கு. So yeah, 15 full syllabus tests, 11th 12th ஓட எல்லா சாப்டர் and then unit test இருக்கு. அதுக்கப்புறம் whatever notes I'm having, this PDF will be uploaded along with the link to this video in the app, and then you're having daily MCQs கூட அதில். ஸோ யா, ஃபிசிக்ஸில் என்னென்ன சாப்டர் படிக்கணும்? ஃபிசிக்ஸில் இட்ஸ் யூஸ்வலி 12th அதிகமாக கேட்பாங்க. 11th will be கொஞ்சம் டிஃபிகல்ட். 12th will be a bit easier to understand for most people because semiconductors எல்லாம் ஈஸியாக பண்ணிடலாம், ரைட்? Try focusing on electricity, magnetism, okay, nuclear physics, semiconductor அந்த சாப்டர்லாம். ஓகே, மாடர்ன் ஃபிசிக்ஸ் மாடர்ன் ஃபிசிக்ஸ் ஃபுல்லாக, and then electricity, magnetism. This 12th இது. 11th இதில் thermal physics is tricky, okay, to understand for few. கொஞ்சம் கடுப்பாக தான் இருக்கும். அதை வந்து யூ ஹோல்ட் இட் பிகாஸ் அதில் வந்து கொஷின்ஸ் வந்து அவ்வளோவா கேட்க மாட்டாங்க. பட் மெக்கானிக்ஸ்லேருந்து கேட்பாங்க, ஒர்க் பவர் எனர்ஜி, லாஸ் ஆஃப் மோஷன், அதுலேருந்து கேட்பாங்க. ஸோ ஃபோக்கஸ் ஆன் தெம், தோஸ் சாப்டர்ஸ் கொஞ்சம் அதிகமாக தேன் thermal physics திங்ஸ். அண்ட் 11th ஆல்சோ ஆசிலேஷன்ஸ்லேயும் வந்து தில் பி 1 question அப்படி தான். என்டையர் thermal physicsல டூ questions அந்த மாதிரி தான் வரும் யூஸ்வலி, 2 or 3 ரேராக. நீங்கள் தெர்மோடைனமிக்ஸ் கேடிஜிலாம் வந்து ரொம்ப டைம் பண்ணுறதை விட ட்ரை புட்டிங் இட் மோர் ஆன் தி மெக்கானிக்ஸ் ஸ்டப்ஸ். ஓகே, ஸோ யா, மெக்கானிக்கல் ப்ராப்பர்ட்டி சாலிட்ஸ் அதுலேருந்து எப்படி ஒரு கொஷின் வந்துடும், ஒரு சாப்டர்லேருந்து கண்டிப்பாக வந்துடும். யூனிட்ஸ் அண்ட் டைமென்ஷன்ஸ் ஃபர்ஸ்ட் லெக்சர் விச் ஐ டுக், அதுலேருந்து கேட்பாங்க. அது மோஷன் பிளேன், ஸ்ட்ரெயிட் லைன், லாஸ் ஆஃப் மோஷன், ஒர்க் பவர் எனர்ஜி, and then system of particles in rotation motion. This entire thing carries a higher weightage. Okay, and I'm also in test series batch. Okay, then appo avangale they'll definitely give you a question paper for the entire month of April. Don't worry. Adiyum thandi, if you want more practice, okay, than the studying, try solving questions again. Try solving a different papers which you can get it easier in Telegram la. Okay, which is it's ethically wrong, but when you when you see it in a different way, நான் சொல்றது, but still it benefits our preparation. So I don't, and when you become good physicians, you'll become physicians, of course. There are people who will be benefited as well. So yeah, okay, anything else? Yeah, if I were to tell about the board exam க்கு தனியா ஒரு செக்மெண்ட் இருக்கு, tips and all. I forgot about that because I didn't do it. And also when you solve the grant test, yeah, you'll be ranked amongst those people who also wrote the exam. Okay, so கிராண்ட் டெஸ்ட் எழுதின எல்லாத்தோட எல்லாரு கூடயும் யூல் ஹாவ் ஒரு ரேங்கிங் சிஸ்டம் மூலமாக யூல் ஹாவ் யுவர் பொசிஷன், நீங்கள் எங்கே இருக்கீங்க, யூல் நோ தட் ஆஸ் வெல். மார்க் டெஸ்ட் டே பிஃபோர் நீட் எக்ஸாம் வரைக்கும் கண்டினியூ பண்ணுமா? ஆனால் நோ, இன் மை ஒப்பீனியன் நோ. நீங்கள் ஏன்னா நீட் எக்ஸாமுக்கு முன்னாடி ஒரு 2 days கேப் விடுறது இன் மை இட்ஸ் பெட்டர்னு நினைக்கிறேன். டெய்லி ஃபிசிக்ஸ்க்கு எவ்வளோ டைம் ஸ்பெண்ட் பண்ணணும்? ஆனால் ஃபிசிக்ஸ் ஹை வெயிட்டேஜ் சாப்டர் சொல்லியாச்சு. ஃபிசிக்ஸ் எவ்வளோ டைம் ஸ்பெண்ட் பண்ணணும்? it still depends on how much you know. If you're studying for 10 hours ஒரு நாளைக்கு, put 2 or 3 hours in physics, அவ்வளோதான். பட் உங்களுக்கு ஃபிசிக்ஸில் தெரியல. இஃப் யூஆர் ஸ்ட்ராங் இன் பயோகெமிஸ்ட்ரி அண்ட் வீக் இன் ஃபிசிக்ஸ், அப்படின்னா it could be 7 hours as well. So everything depends on how much you have already prepared, how much you already know. So I can't simply tell, but what I can tell you is how much I spent. Okay, it used to be morning physics konjam, adukaprom for 1 and 2 hours, and then nadula bio and then chemistry konjam, again physics konjam. Okay, roughly 3-4 hours. Okay, that's how it was. Umar, I am 11th moving 12th student from Velamal. How do I finish syllabus for NEET prep? I'm still teaching so terrible. How to cover in home? Is it possible in 1 year? Definitely, it's possible. Guys, I'll tell you one thing. My entire 11th, it didn't go very well. Okay, I studied. I did score okayish marks, but it wasn't enough to get into this college. Okay, and then 12th poche, 12th I studied a little with a little more seriousness and little more, yeah, it went decent. And then they had revision. Okay, October to January, and the October, November, December, January, 4 months la entire 11th and 12th fulla they'll revise. Okay, fulla. Since I didn't know 11th la konjam, 12th la konjam ellame, I had to study it from the first. Okay, and in 4 months they finished the syllabus, and in 4 months I was able to study it completely, entire 11th and 12th. Now you need to be checking what are heavy weightage chapters in physics. Yeah, mechanics. Okay, Newton's laws of units and dimensions. Okay, அதிலிருந்து கண்டிப்பாக கொஷின் வந்துடும். Motion in a straight line plane, அதிலிருந்து 1 or 2 questions. Laws of motions, work per energy. See, and the split is 45-55 இருக்கும். Okay, 12th கொஞ்சம் அதிகமாக இருக்கும் mostly. So 12th வந்து electricity, magnetism, big units, அது important. And then you're having your ஆப்டிக்ஸ்லேருந்து யூஸ்வலாக கொஷின்ஸ் வரும். ஆப்டிக்ஸ், ஓகே, ரே ஆப்டிக்ஸ் அண்ட் வேவ் ஆப்டிக்ஸ், அதுலேருந்து அது everything is important still if you want to score very well. Okay, 180 out of 180, that's your target. But if you are stuck in the middle, and if you have covered ellame to some extent, I would suggest to study everything. Okay, but if you haven't, okay, appo magnetism, electricity, modern physics நிறைய கேட்குறாங்க இப்போலாம். And this is for 12th. And ray optics, wave optics, obviously கொஞ்சம் basic. So this covers the entire 12th. 11th thermal physics கொஞ்சம் கம்மியா. Okay, don't focus much on it. They don't ask questions from those chapters usually. I mean, the questions are being asked, but not that difficult and not that many questions as well. So அதில் வந்து அவ்வளோ டைம் ஸ்பெண்ட் பண்ண தேவையில்லை, பட் ரேதர் புட் தட் ஆன் மெக்கானிக்ஸில் ஃபுல்லாக. ஓகே, ஜேஇ லெவலுக்கு ஃபிசிக்ஸ்க்கு தேர் இஸ் a புக், ஐ திங்க் யூ would know சிங்கேஜ். அந்த புக் நல்லாயிருக்கும். ஓகே, தட்ஸ் ஃபார் இன்டர் அந்த லெவல். இந்த செங்கேஜ் அந்த புக் நல்லாயிருக்கும். அண்ட் தென் யூ ஹேவ் ஹெச்சி வர்மா. ஹெச்சி வர்மா இஃப் யூ சால்வ்னா போதும், ஐ திங்க் இட் வில் பி சஃபிஷியன்ட். I've taken your course. Can you solve previous question in that video? In which video? Physics last minute revision ku just formulas guys, full on formulas. கொஞ்சம் theory படிச்சுக்கோங்க and then formulas and then solve it. Okay, before when with sufficient practice formulas எல்லாம் உங்களுக்கு மைண்ட்லேயே எழுந்திருக்கும். ஓகே, யூனிட்ஸ் எல்லாம் பார்த்து வச்சுக்கோங்க, சின்ன சின்ன வேல்யூஸ் எல்லாம் பார்த்து வச்சுக்கோங்க. இப்போ யூனிவர்சல் கிராவிடேஷன் கான்ஸ்டன்டோட வேல்யூ அதுவும் கொடுத்துருவாங்க. ஸோ இட்ஸ் யூஸ்வலி ஃபார்முலாஸ் தான், யூ ஜஸ்ட் ரிவைஸ் தெம் இன் தி எண்ட் போகிறதுக்கு முன்னாடி. I solved ஹெச்சி வர்மா பிகாஸ் ஐ டென்ட் ஹாவ் செங்கேஜ். நான் படிச்சிருக்கேன், ஐ சால்வ்டு கொஞ்சமாக, லிட்டில். ஓகே, நீங்கள் ட்ரை ஹெச்சி விச் இட்ஸ் குட். ஃபார் ஜேஇ இட் வில் பி சஃபிஷியன்ட் பிகாஸ் அதில் வந்து the concepts explained in H.C. Verma is totally different. The way he explained it in his books, they are really, it's really good. Okay, yeah, okay, all right, I think I start the class. It's 6:43 now. All right. ஆனால் டெஸ்ட் சீரிஸ் எப்படி யூஸ் பண்ணுறது? Go to the app. நடுவில் யூ ஹேவ் டெஸ்ட் சீரிஸ். அதில் வந்து லைவாக இருக்க கிராண்ட் டெஸ்ட் எல்லாம் உங்களுக்கு தெரியும். அதில் போய் யூ ஜஸ்ட் அட்டெம்ப்ட், அவ்வளோதான். அவ்வளோதான். ஜஸ்ட் go to the app and attempt. Okay, guys, ஒரு நிமிஷம், I got stuck here. Yeah, it's still working well. Correct. Yeah. Okay, let's finish this off. So guys, smash your like button. Okay, right. So இதை பற்றி பேசியாச்சு. And for those who don't know me, I'm Rihan, second year MBBS student from Madras Medical College, here to take electric potential and capacitance for you guys. Okay, I'll try to make it as simple as possible. Capacitance thing is something I in the entire 12th pathina, apart from ray optics, which you can observe in real life to some extent. See, even electric potential and magnetism, with experiments you can, but நீங்க not everyone would have seen a capacitor being charged in real life. But what you would have seen are cars moving together in the same velocity. Okay. Yeah. So in the 11th one, the people can visualize it very easily. Okay, because we in from our childhood day and we throw stuff, projectile motion. Okay, we have went in cars, we lift stuffs. Okay, we have seen so many levers are pulley are we have seen so many stuffs. Okay, in our real life practical app. So it's little easier to understand. But when you come into electricity, okay, and magnetism, it gets a little trickier to actually understand few stuffs. Okay, I'll try to make it very simple in the lecture lab, don't worry. 5 minutes in the end of it to solve numericals. uh, when you're teaching chapter wise, that previous year questions, if you solve previous year question in the chapter wise video. Oh, you want me to solve previous year questions in these videos only? If I have time now, I'll solve it definitely, because this chapter is a little huge. Okay, understanding the concept comes first. Okay, அதுக்கப்புறம் தான் formulas, அதுக்கப்புறம் தான் numericals. I'll solve. I have questions. I have questions, PYQs எல்லாம். Yeah, I'll solve it. Okay, fine, let's not waste your time. All right. Okay, I think it's clear. Okay, all right. Okay, okay, just 1 minute guys. I think someone just give me a minute. Okay, 1 minute. All right, really sorry. Yeah. Okay, fine, paka. Let's start the class with what is electric potential. Okay, fine. Electric potential energy. இன்னும் வந்து நம்ம இந்த we are electrostatics isn't covered for you guys, I'll take the class on Friday, don't worry. But this is your electric potential and capacitance. Okay, fine. Let's see what it is. Electric potential is the amount of work done in bringing a unit charge from infinity to a point in the electric field. And if you teach in Tamil while teaching, it will be help me to understand. Okay, Tamil na okay, na Tamil பேசுறேன், okay. But I can write only in English. So basically இப்போ பார்த்தீங்கன்னா உங்ககிட்ட ஒரு சார்ஜர், ஒரு எலக்ட்ரிக் ஃபீல்டு இருக்கு. ஓகே ஓகே நம்ம வந்து கிராவிடேஷன் சாப்டர் டிஸ்கஸ் பண்ணியிருப்போம். கிராவிடேஷனல் பொட்டென்ஷியல் எனர்ஜின்ட்டு. இட்ஸ் நத்திங் பட் ஒரு மாஸை, ஒரு பாயிண்ட் மாஸை, ஓகே, இன்ஃபினிட்டிலேருந்து ஒரு பாயிண்ட் இந்த கிராவிடேஷனல் ஃபீல்ட் கொண்டு வரக்கு எவ்வளோ எனர்ஜி. ஓகே, இன்ஃபினிட்டியில் we are considering அதோட பொட்டென்ஷியல் எனர்ஜி டு பி 0. ஓகே, ஸோ when it comes close எவ்வளோ ஒர்க்கு நம்ம பண்ண வேண்டியதாக இருக்குது. தட் இஸ் தி கிராவிடேஷனல் பொட்டென்ஷியல் எனர்ஜி of that point of that unit mass at that point. Okay, fine. So இப்போ electric potential energy is nothing but we have, okay, before getting into potential, field. Okay, electric field is nothing but the in the where electric potential is felt. Okay, it might be a little confusing. I think everyone knows what field is. Okay, the area around a charge, say, where its force is felt. Okay, எவ்வளோ தூரம் அதோட ஃபோர்ஸ் வந்து எங்கெல்லாம் எக்ஸர்ட் பண்ணுதோ அதெல்லாம் வந்து அதோட ஃபீல்டில் வரும். ஸோ அந்த ஃபோர்ஸ் எக்ஸர்ட் பண்ணுற ஏரியாவுக்கு உள்ளே வர ஒரு பாயிண்ட் சார்ஜ்க்கு எவ்வளோ எனர்ஜி தேவையோ தட் இஸ் எலக்ட்ரிக் பொட்டென்ஷியல். ஃபைன். இட்ஸ் யூஸ்வலி இந்த யூனிட் சார்ஜ் இருக்கு இல்லையா, இட்ஸ் டேக்கன் ஆஸ் அ பாசிட்டிவ் சார்ஜ். ஓகே, எலக்ட்ரோஸ்டாட்டிக்ஸ் நான் டீச் பண்ணும்போது ஐ திங்க் இட் வில் பி கிளியர். எலக்ட்ரோஸ்டாட்டிக்ஸில் there has been a சின்ன ஸ்கெடியூல் சேஞ்ச். அதனால தான் வந்து எலக்ட்ரிக் பொட்டென்ஷியல் இஸ் கம்மிங் பிஃபோர் எலக்ட்ரோஸ்டாட்டிக்ஸ். ஸோ யா, பாசிட்டிவ் சார்ஜ் வந்து நான் இன்ஃபினிட்டிலேருந்து கொண்டு வரேன் டு அ பாயிண்ட் இன் தி எலக்ட்ரிக் ஃபீல்ட். எலக்ட்ரிக் ஃபீல்ட் இஸ் தி ரீஜன். Magnetic field is the region around the magnet where a magnet sort of force is felt. அதே மாதிரி to bring it in this point. Okay, this is basically what it is. Okay, இங்கே வரக்கு how much energy. Okay, fine. This electric potential is a scalar quantity. Okay, fine. Okay, இதோட SI யூனிட் வந்து வோல்ட். ஓகே, okay, expression. How is this expressed? Now this இங்கே சொன்னேன் இல்லையா, electric field. The electric field is produced by a charge. Okay, yeah. Charge produces electric field. Okay, இந்த சார்ஜ் ப்ரொடியூஸ் பண்ணுற எக்ஸர்ட் பண்ணுற ஃபோர்ஸ். ஓகே, அதால் ஒரு ஃபீல்டு இருக்குது. அது சார்ஜ் எக்ஸர்ட் பண்ணுற ஃபோர்ஸ் எக்ஸர்ட் பண்ணுற ரீஜன் இஸ் ஃபீல்ட். அதில் வந்து ஃபார் சம்திங் டு கம் அண்ட் ஸ்டே இங்கே இந்த பாயிண்ட்டுக்கு இட் ரெக்வயர்ஸ் சம் எனர்ஜி. இட்ஸ் ஒர்க் டன் டு பிரிங் தட் சார்ஜ் ஃப்ரம் இன்ஃபினிட்டி டு ஹியர். ஃபைன். இங்கே நம்ம பார்த்துருப்போம் in the it's similar to Newton's law of gravitation. Okay, Coulomb's law of force between two charges is nothing but k q1 q2 by r square. This is the force. Okay, in the force one day, now see, there is a positive charge here. Okay, now the definition is right, but just understand. Okay, there is a positive charge here and I'm having a unit positive charge here. Okay, it's close, super close. This distance is negligible vechukko. And in the point, the charge வந்து இந்த பாயிண்ட்ல இருந்து to a distance of r மூவ் ஆயிருக்கு. Okay, distance of r மூவ் ஆயிருக்கு. This is a repulsive force between two positive charges. Okay, okay, இந்த பெரிய சார்ஜோட இந்த பெரிய சார்ஜ் வந்து Q, capital Q, and இது வந்து யூனிட் சார்ஜ். ஓகே, 1 coulomb. So it has been pushed from 0 distance to a distance of r. Okay, fine. இது புஷ் பண்ண ஃபோர்ஸ் எவ்வளோ? K Q into 1 divided by r square. The force in neta into r, right? KQ by r is the potential energy here. Now you may ask me, this is wrong. Okay, why is this wrong now? Since r varies, okay, we can't directly write the force to be same instantly, because இங்க வந்து r will be ரொம்ப கம்மியா initially. R tends to 0 to r வரைக்கும் இருக்கும். So we have to integrate it properly. Okay, but the basic idea of the expression comes from here. Okay, when the charge is here, it will experience a force of k q by r square. Okay, okay, and the force at a distance of r, this is what its potential energy will be. Since it's repulsive, the potential energy here is positive. Okay, attractive, it's taken as negative. Okay, then paka attractive வந்து இப்போ பாசிட்டிவ்க்கும் நெகட்டிவ் சார்ஜ்க்கும் it's attractive. Okay, so அப்போ வந்து it's negative minus k q by r. Positive, it's repulsive, so it's taken as plus kq by r. I hope இது வரைக்கும் clear. That's okay. Anna, writing in English I can understand some technical words. I'm not getting views. Words in Tamil, I will grasp the concept more. Okay, hi brother, I have actually pursued the test series from Messenger. I'm not able to be the question blank over there. Some authoritative reply. Okay, I am not able to view the question bank over there. Well, it works fine though. நல்லா தான் கரெக்டாக தான் இருக்கு. Is this any specific chapter or okay, just let me know. And also question banks விட இந்த டெஸ்ட் சீரீஸ்ல தான் வந்து you'll have grand test விட you'll have chapter wise questions இதில் தான் இருக்கும். Chapter wise 45 questions, whichever we people took, it's in the test series part. Okay, chapter wise chapter test. Okay, question bank it's different, okay? It has lesser questions, but still you can practice. It's 15-20 MCQs per chapter. uh, it's working fine for me. I'll still address your query கொஞ்ச நேரம் கழிச்சு. I'll ask the admin to check on it, okay? Okay, fine. App related queries, you just let comments la போடுங்க. I'll check it out, okay? So, this is the expression. It's nothing but work done per unit charge. Okay, work done per unit charge. So unit charge it's k q by r. If it's a different charge na, this will be, if say either 1 coulomb of charge lama, if it's something else, it will be k q1 q2 by r. Okay, fine. Paka. All right. Okay. A positive charge, this is a point to be noted, a positive charge moves from higher potential to lower potential. Any charge for that matter, okay? Let's see how this work applies for the both positive and negative charges. Okay. But still again, the concept of charges இருக்கு இல்லையா, இது வந்து it is explained in a very beautiful manner in H.C. Verma. Okay, the concept of charge is why some are positive, why some are negative. Now electrostatics எடுக்கும்போது I will teach you, but still if you want to check it out, I mean if you want to know it, இப்போவே go and check it out in H.C. Verma, இந்த bookல இருக்கும். Okay, it's beautifully explained. Okay, yeah, 1 minute, yeah. இப்போ நீங்கள் பார்த்தீங்கன்னா, when I have a wedge இந்த மாதிரி and a ball is kept here, it is at height h ன்னு வச்சுக்கோங்க. This is ground level. Okay, the ball will definitely move from the higher potential area to lower potential area. The exact same thing with charges, but charges இது எப்படி ரெப்ரசென்ட் ஆகுதுன்னா, when you take an electric field, okay, the field oda source is இது. Electric field is nothing but force per unit charge. Okay, fine. So force acting upon per unit charge is electric field. Okay, adha vande to have understanding, I told you the region around the charge where its force is felt. So you're having here a charge. Initially idha vande R1 வச்சுக்கோங்க. After some time it went here because the force is applied in this direction. Okay, கொஞ்ச நேரம் கழிச்சு இந்த சார்ஜ் இங்கே போயிடுச்சு. It's at a distance of R2. இப்போ பக்கா ஓகே, R1 R2. இப்போ நீங்கள் பார்த்தீங்கன்னா இங்கே இருக்கிற பொட்டென்ஷியல் இஸ் இந்த பாயிண்டில் இட்ஸ் KQ by R1. Okay, it's KQ by R1 and here it's KQ by R2. Q being the charge which is producing the field. Okay, fine. இப்போ நீங்கள் பார்த்தீங்கன்னா R ஓட வேல்யூ போக போக இன்க்ரீஸ் ஆயிருக்கு. That means போக போக the potential, okay, the potential of the object kept decreasing. அதாவது this one was higher than R2, was greater than KQ by R2. Paka. So it's moving from higher potential to low potential. Fine. Now let's see for negative charges. Take negative. Okay. Initially it will be here KQ by R1 minus KQ by R2. Either on numerical value, just taking the number, it will be more than this. Okay, but when we consider the negative sign inga அப்படி ஆப்போசிட் ஆயிருமா obviously. So இப்போ வந்து இங்க வந்து it has higher potential, இங்க வந்து it has lower potential. Yeah, so this is what it is. Okay, basic stuff. Paka. Okay. Now இது வந்து electric potential. Okay, that is for per charge. Okay, now இங்க வந்து நான் ஏற்கனவே சொல்லியிருப்பேன், this is for a collective thing. Okay, when you, I'll add a page, one நிமிஷம். When you have a field, okay, you have a field இப்படி, I promise it will make sense when you have studied electrostatics chapter. Okay, but still, okay, I'm having a field in the மாதிரி. Okay, இந்த ஃபீல்டில் இந்த பாயிண்ட் இருக்கு இல்லையா, இந்த பாயிண்ட், everything has same potential, equipotential plane, and the plane perpendicular to it. Why am I calling it equipotential? Because you see, this is the source of the field. Okay, source லேருந்து ஒரே டிஸ்டன்ஸில் இருக்கு, கரெக்டா? ஓகே, ஸோ ஒரே டிஸ்டன்ஸில் இருக்கிறதால the field, because of it, the source field, I mean the potential at this point, at these points, okay, it will be same, it will be nothing but KQ by R. Okay, and also notice, for a point, I mean for a set of points to have equal potential, அங்கே வந்து அது அந்த surface, if you mark it out, the field is perpendicular to the surface. Okay, fine. இது வந்து ஒரு பெரிய ஃபீல்டுக்கு எடுக்கிறேன். இப்போ say I am having a point positive charge. ஓகே, இந்த பாசிட்டிவ் சார்ஜ்க்கு இந்த பாசிட்டிவ் சார்ஜ்க்கு any sphere around it, okay, any sphere, not a circle but a sphere. I'll discuss this topic again, but still, any sphere around it, okay, and the sphere la irukra ella points me vandu will have the same potential because the radius is same. இங்கே வந்து say this is R radius, this is R radius, இங்கே வந்து it's KQ by R. இங்கே the potential is nothing but KQ by small r. Okay, it will be the same everywhere. Pakka. Okay, fine. This is what I want to tell you. Hmm. Hmm. This is these surfaces are called as equipotential surfaces. We'll get into this in a bit. Okay, equipotential surfaces. Okay, any doubts, Idariko? Thumbs up. Okay, thank you, Safara. Fine. Okay. Due to a point charge, இப்போதான் we discussed. Okay, when you have a point charge, say Q. Okay, in the point charge at some point, okay, point charge at some or some space, okay, some point in the space, the field, I mean the potential at that point, okay, the potential at that point is nothing but K Q by R. Paka. Okay, it's nothing but when it if it derive panona, it's nothing but in work done is integral f dx. Okay, okay, fine. Force is nothing but K Q by x square, where x tends to 0 to R, and then dx. நான் இங்கே derive பண்ணாமல் நான் சொல்லியிருப்பேன். இங்கே derive பண்ணால் this is the proper way to derive. இது வரும் கரெக்டாக. when you integrate minus x power minus 2, it will become x power minus 1, and yeah, this is it. Okay, fine. It's so potential is nothing but work done per unit charge, and work done for a charge which is not for other than unit charge வந்து you multiply Q with it. Okay, the அதோட charge with the potential, you will find the energy required for it to get into that point. Okay, fine. This is a important point. Okay, when you ஒரு சர்க்கியூட்ல கரண்ட் எலக்ட்ரிசிட்டியில் நம்ம பார்ப்போம், பட் ஸ்டில் ஐ வாண்டட் டு டெல் யூ ஹியர். ஒரு சர்க்கியூட்ல, okay, when you have a circuit and you turn on the light, I mean turn on the switch, the light lights up immediately. Okay, we know that potential causes, okay, potential difference, okay, causes an electric field. An electric field causes electrons to move. Okay, 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 I just wanted to tell you. But when these electrons move, okay, their speed is, their velocity is very less. Okay, electrons are so tiny, and they won't be able to move from the point where you turn on the switch to the light bulb immediately. Okay, when you turn on the switch, okay, a circuit gets completed. Okay, and the circuit complete ஆகும்போது there is a potential difference. Okay, the potential difference, okay, battery ஓட 10 terminalsum ஒரு positive or negative, it will have some volts. அதாவது some volts nothing but it has some set of energy difference between its poles, so that any unit charge to come into that field would require our energy. Okay, that's how we define it. So a potential difference causes an electric field. This electric field causes movement of charges. These movement of charges causes what? Energy transfer, causing the light bulb to glow. இது வந்து நம்ம கரண்ட் எலக்ட்ரிசிட்டியில் கொஞ்சம் டீட்டெயிலாக பார்ப்போம், பட் still I wanted to tell you here. Okay, the takeaway from this lecture should be potential difference. Here and there will be electric field. Electric field and there will be potential difference. Fine. Okay. Paka. Okay. Okay, fine. Electric dipole munadi. What do we have? Electric potential again. Okay. Electric dipole oda munadi I'll discuss a certain things munadi inga. Okay. Due to a system of charges. System of charge. What will be the potential? Okay. Pop. இப்போ ஒரு பாயிண்ட் இருக்கு. ஓகே, இந்த பாயிண்ட் வந்து எக்ஸ்ன்னு வச்சுக்கோங்க. இந்த பாயிண்ட் சுற்றி சே ஐம் ஹேவிங் 3 சார்ஜஸ், Q1 சார்ஜ், Q2 சார்ஜ் அண்ட் Q3 சார்ஜ். ஓகே, which are at the distances A, B and C. ஓகே, இப்போ இந்த பாயிண்ட்ல okay, இந்த பாயிண்ட்டுக்கு we'll go with definition. Okay, from infinity I'm bringing up unit charge from infinity to this point. Okay, infinity in the point I'm bringing a unit charge. Okay, அதுக்கு எவ்வளோ எனர்ஜி தேவைப்படும்? It's nothing but the field, the potential of this charge and the potential of this charge and the potential because of this charge. Okay, ஏன்னா all these 3 charges they exert force in this point. Correcta? Okay, you can have either or a net field வச்சு net potential கண்டுபிடிக்கலாம். எப்படின்னா, see here, since they are arranged in such a way, okay, they are arranged in such a way, they are all positive charges. இப்போதைக்கு இது வந்து to a positive charge here, it will exert force in this direction and this will exert force in this direction and this will exert force in this direction. Okay, fine. In the point, and there will be some angle, definitely there will be some angle, and either one day we can resolve components, resolve cos components and sine components of 2. Okay, component resolve பண்ணி together okay, these two will get cancelled, அதை cancel பண்ணி remaining எது இருக்கோ, it's அது வந்து கொஞ்சம் அவசியம் இல்லாதது, but still you could do that. Okay, net field என்ன directionல இருக்கோ net field கண்டுபிடிச்சு and then you can find net potential at that point, or it can be as simple as K Q1 by A plus K Q2 by B plus K Q2 by C. This is the net potential at that point. Okay, very 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 simple. Okay, if you have a negative charge here, just add negative sign. Paka? Clear? Done? Okay. All right. So yeah, no reply. I think I'll move on. Okay, I have one question. Say the same thing, same arrangement. What if they're in a triangle? Okay, or a triangle in there. Okay, triangle. We have two charges and 1 point. Okay, we are not considering the potential of a system inga. Just one point la, what is the potential I'm going to find. Say 4 coulomb of charge, of positive charge at 2 points of an equilateral triangle. Okay, or equilateral triangle 2 points having charge, positive charges. Say in the say 1 meter 1 meter. This equilateral triangle or length வந்து 1 meter of each side. Okay. In the point the potential will be nothing but K into 4 into 10 power minus 6 by 1 because of one positive charge plus K into 4 into 10 power minus 6 divided by 1 because of another positive charge. But just listen. Idhula vande when you have to find, when you're supposed to find field inga, okay, field is nothing but force per unit charge, and force is a vector quantity. So when you're using, when you're finding net field at a point, okay, net field on the point la evlonu kandupidikum bodhu, since force is a vector quantity, na inga vande இந்த மாதிரி டைரக்டா ஆட் பண்ணுவேன். I have to use vector addition இங்க. Okay, because field வந்து இப்படி இருக்கும் and இப்படி இருக்கும் இந்த டைரக்ஷன்ல. ஸோ இப்போ வந்து நான் நெட்டாக வந்து இப்படி ஒரு ரிசல்டன் போகும், இப்படி ஒரு காம்பனன்ட் போகும், இப்படி ஒரு காம்பனன்ட் போகும், இப்படி ஒரு காம்பனன்ட் போகும். நெட் ரிசல்டன்ட் will be in this direction and அதோட ஃபீல்ட் ஐ ஹேவ் டு அதோட நெட் ரிசல்டன்ட் வச்சு தான் வந்து சி நெட் ஃபீல்ட் அந்த பாயிண்ட்ல. Okay, that's a different story. But when you're finding potential, since potential is a scalar quantity, it's as simple as this. It's a scalar quantity. Okay, paka, done, clear. All right. What is K? What a value? One by 4 pi epsilon naught, or it's 9 into I'll write it down here. Epsilon naught or Newton meter square by Coulomb square. 9 into 10 power 9. Okay. Hi, what is your name, sir? Please told. My name is Rihan. Okay. Fine, paka. I hope you are clear. Okay. Fine. Okay, guys, just hold on a minute. Okay. I remembered pretty interesting question. It's interesting now. Just look at this, okay? It's simple, yet so well constructed in its own. So concept is simple, okay? Once you know concept, you can solve any questions. And okay, fine. Let's take black and yellow, okay? For every odd distance of x, say x is the distance, okay? X is no fixed distance. For every odd distance, increase in distance, on there you have a positive charge. And for every even increase, you have a negative charge. Okay? To infinity. So you have infinite number of positive charges and infinite number of negative charges as well. Fine. And everything is in an arithmetic progression. You have plus 2 plus 2 plus 2 for both. Okay? It goes on. So you have 6x distance and then 7x distance you have a positive charge. So yellow எல்லாம் வந்து negative, yellow negative, black positive. Okay, paka? Yes. Okay. So if a black are positive and yellows are negative. Simple, basic, simple, very, very simple. Okay. If you want to find, so net வந்து positive potential negative பார்த்துக்கலாம். Okay. So net positive charge potential will be kq by x plus kq by 3x. It will go on. Okay. So I can take it kq by x plus into 1 by 1 plus 1 by 3 plus 1 by 5 plus 1 by 7, and it goes on. Okay. And net negative or the it's nothing but kq by x into 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 10 and so on. Okay, this is in an arithmetic progression. Okay, this is an arithmetic progression. ஆனா இங்க பாத்தீங்கன்னா it gets subtracted, it gets halved. Okay, I mean it gets reduced as it goes. Okay, so now tell me in the comments what progression this is in. This is in arithmetic. Okay, this is plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. In what progression are these two terms in? Let me know in the comments because this chapter is huge. Okay, so no one's answering. It's fine. Okay. Wait, it went away. Reasons, yeah. Okay. Now I can rewrite the exact same thing as k q by x into 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 plus 1 by 7 and so on. Right? No. No. Harmonic progression, no. But here, okay, when you see, still, when you see, இது இவங்களோட reciprocals are in harmonic progression. I mean, are in arithmetic progression. So you can call it in harmonic progression. But since they are alternating between the signs, positive and negative, they are alternating harmonic series. Okay, fine. It's not necessary for NEET, but still, okay. You call it a logarithmic series. Okay, இந்த மாதிரி இருக்கும்போது this is just equal to, just know, NEET level இவ்வளோ கேட்க மாட்டாங்க, but still is equal to ln of 2. Okay, just remember this. Okay, and yeah, so it will be k into q ln 2 by x. Paka, this is what it is. Fine. Clear? Oh, okay. A harmonic progression is different. Yeah. Okay. Safura, I hope. An electric dipole. Dipole na enna? A dipole is nothing but a system of, okay, two opposite charges of the same magnitude separated by a distance. Okay, you have two opposite charges of the same magnitude separated by some distance. That's a dipole. Okay, so you have same plus q இங்க இருக்கு, கொஞ்ச தூரம் தள்ளி you have a minus q இங்க. Exact same magnitude, opposite signs, distance வந்து it's separated. And also to make calculations easier, okay, in the distance between them, it's taken as 2a. Okay, so the midpoint length, this will be a and this will be a. Fine, this is what a dipole basically is. Fine. இப்போ இந்த டைபோல்ல, can you tell me from where the field is? Field direction எழுதணும்னா it will be from positive to negative இப்படி within the dipole. Right. 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 now I introduce you to a newer term called as dipole moment. Okay, a dipole moment. It's simple. Okay, it's nothing but q into 2a, charge of either into the distance between them, and this dipole moment is a vector quantity because the distance between them is a vector thing. So yeah, so it's denoted by p bar equals to 2a q p cap, where a is the distance between them, q is the charge of either one. Okay, this is the topic where people will feel little difficult. Okay, in the thing, it's so this place, I don't know what to do about that. Seriya maatidhu. Yeah, okay, டைபோல்னா இதான். ஏன்னா வந்து 2a the distance between them, ஏன் 2a எடுக்கிறோன்னா to make calculation easier. ஏன்னா இல்லை வாட் calculationனா இனிமேல் தான் we're gonna see. This is the electric potential எழுதியிருக்கேன்னா. Okay, but still I'll do it here. Okay, fine. Now இந்த டைபோல் இருக்கு இல்லையா, இந்த டைபோலால் எலக்ட்ரிக் பொட்டென்ஷியல் at a point கண்டுபிடிக்கலாம். This is my dipole, positive q, negative. Okay, say at a point here. Okay, correct, this is the middle point. This is a, this is a as well. Okay, it's a distance. This point is at a distance of, okay, okay, R1 and R2. Okay, இப்போ இந்த பாயிண்ட்ல potential due to the positive charge will be, potential due to the positive charge will be, this is your electric potential due to a dipole. Okay, fine. R1, R2, this is R. Fine. Okay, say positive charge ala it's V1, negative charge ala it's V2. இது ரெண்டோட சம் தான் வந்து it will be the net electric field at that point, electric potential at that point. Okay, V1 is nothing but K Q plus KQ by R1. Okay, V2 is nothing but minus KQ by R2. Okay, fine. So net எழுதணும்னா it's nothing but K is nothing but V1 plus V2 potential due to 1 plus potential due to other one. We saw it here exact inga right. இது எப்படி எழுதலாம், K Q by R1 minus K Q by R2. Okay, fine. I'll write continue it here. K Q into 1 by R1 minus 1 by R2. Okay, இப்படி எழுதலாமா? Yes. Okay. Now 1 by R1 minus 1 by R2 எப்படி எழுதலாம்? Say this is theta. Okay, this is theta. Okay, this is theta. You can write 1 by R1 minus 1 by R2 as 2a cos theta by R square. Okay, this requires a little bit of derivation. I think it's unnecessary for a one-shot video. Okay, just remember this is what it is. Okay, R1 minus R2 is can be written as 2a cos theta by R square, where R square is this thing. Okay, this distance from the center of the dipole. Derivation வேணா சொல்லுங்க, I'll tell you, but still it's k q into 2a cos theta by R square. Okay, what is q into 2a? Dipole moment. Fine, so it's nothing but k cos theta by R square. Okay, but since you can't use bar here because technically potential is not a vector quantity, but still dipole moment is. Okay, but taking just its magnitude. Okay, this bar is wrong because potential is not a vector quantity but a scalar. So cos theta by R square. Fine. Now there is a significance to this cos theta idla. Okay, யாருக்காச்சும் வேணுமா derivation for y 1 by R1 minus 1 by R2 is 2a cos theta by R square? It's just trigonometry, basic trigonometry. Okay. This cos theta has its own significance. Okay, no one யாருக்கும் வேணாம். Okay, fine. So this cos theta இருக்கு இல்லையா, when cos theta value எப்படி இருக்கும்? It's you know how a cosine wave goes, right? எப்படி போகும்? Maximum to minimum to maximum எப்படி போகும்? This is your cos wave. Okay, it starts from 1, it goes to 0 at 90, it goes to minus 1 at 180, it goes to 0 in 270 and back to 1 and 360 degrees. Fine. ஆனால் since this is in a straight line, it could be 0 தான், 0 to 1 அந்த ரேஞ்சில் தான் இருக்கும். Okay, fine. So when theta is 0, அதாவது 0னா the potential q minus q, theta is 0 na, it's flat completely, it's here somewhere. அப்போ இந்த பாயிண்ட்ல potential due to the dipole will be k p cos theta is 1, so it's kp by R square. Okay, So this is the maximum potential. This is, or it can be along theta can be 180 as well. Okay, exactly opposite end. Anga the potential will be minus kp by r square if theta is equal to 180 degrees now. Okay, these are the two possibilities. Okay, அதே வந்து when theta is equal to 90 degrees, something different happens. Okay, when it's in 90 degrees, just imagine 90 degrees now, it's exactly the center of the dipole. Okay, dipole central இருக்கும்போது these distances are same. Okay, this distance is same as this one because this is same, this is 90, so hypotenuse same ah irukkum, correct ah, pakka. So when you substitute the formula direct k p cos theta by r square, theta becomes 90 na, cos theta becomes 0. So in the entire surface la, entire perpendicular plane la, the potential is 0. Oh, I just repeated. Okay, due to a point charge, system of charges. Okay, this is a different concept. Okay, fine. This potential is 0 in the perpendicular plane. Fine, pakka. Okay, done. Let's solve few questions. Okay, wow. So let's say inga vande or charge, it's plus 2q. This is an equilateral triangle, by the way. And then you have q and q minus charges. Okay, the distances are same. It's an equilateral triangle, so yeah. Now what we are supposed to find is the dipole moment of the combination. A very classical question. Okay, they usually ask this question எப்போ பார்த்தாலும். Okay, the question this is in, you can find the same in magnetism as well. Okay, the same comes in electrostatics and field as well. So yeah, net dipole moment of the system we are supposed to find. Okay, we know a dipole consists of two charges. Okay, and the two charges are opposite in sign. Okay, one is positive, other is negative. Fine, okay, we know this as well, right? Okay, so can I resolve this charge into two smaller charges of each q and q plus q and plus q charges? Okay, can I do that? Yes, I could do that, right? But still the net magnitude will be plus 2q. Okay, so அதை வந்து the plus 2q plus q and plus q பிரிக்கிறேன். Okay, so it will be plus q and plus q, and still this is your equilateral triangle, distance d, okay, then the minus q, okay. இதான் வந்து இதோட direction of dipole moment. Okay, this is the direction. Okay, fine. So இங்க வந்து it will be nothing but p bar equals to qd. Here p bar equals to q into d. Fine. Okay, but they are in different directions. Okay, one வந்து இப்படி இருக்கு, the other one is in this direction, and the angle between them is 60 degrees, equilateral triangle nala. Okay, so the net dipole moment will be resolve பண்ண என்ன இருக்கும், you have cos component இப்படி, you have two components இப்படி, இங்க you'll have p cos 30 and p cos 30. This will be a p sin 30 and a p sin 30. These will get cancelled, so net dipole moment is p net equals to 2p cos 30 degrees. Okay, okay, fine. Now see, இப்போ அதே டைப்போல், இப்போ இன்னொரு கொஷின், there is an electric field. ஓகேவா, இந்த டாபிக் அகைன் ஐ வில் கம் பேக், பட் ஸ்டில் சும்மா ஒரு இது ஓகே மேலே அப்படி காமிச்சிட்டு போயிடுறேன். an electric dipole is placed here, electric fieldல a uniform electric field. Okay, so the force is constant throughout. Okay, 5 Newton per coulomb na inge 5 Newton per, so it's uniform wherever you go. Okay, you're having plus q inga minus q inga. What forces will this experience? Okay, in an uniform electric field. Okay, it's at an angle of 30 degrees. Okay, and இதை வந்து நான் இன்னொன்று எடுத்துக்கிறேன். I will make a copy. Okay, fine. And what will be in the case of non-uniform electric field? ரெண்டுமே பார்ப்போம். யூனிஃபார்மில் என்ன ஆகும், நான் யூனிஃபார்மில் என்ன ஆகும்ட்டு. ஓகே, this is your non-uniformல, this is uniformல. ஓகே, ஃபைன். 30 degrees, ஃபைன், பக்கா. ஃபீல்டு இப்படி ஆக்ட் ஆகும். ஓகே, force will be in this direction, dissolved forces. Okay, இது 30 degrees this 30 degrees you'll have a cos component acting இப்படி and a sin component acting here இப்படி, sin component and a cos component. Okay, and then here you'll have a exact same thing. This is field 30 degrees, but in the opposite direction this is 30 degrees இப்படி ஆக்ட் ஆகும். ஸோ இங்கே வந்து this will be your sin component and a cos component. Okay, what you have to remember is that this field say it's because of a negative charge. Negative charge alla, the negative is getting pushed away, the positive is getting attracted. Okay, the directions are different in both. Okay, fine. Netta vande there is the field, say it's E. There is 2 EQ sine theta into dipole into A of torque irukku. So it's going to rotate, but there is no translational motion because it's uniform electric field la vande every point experiences same force. So same force act ஆகும்போது you won't have, if it were non uniform na, I'll explain here. Non uniform என்ன ஆகும்னா, இங்க பாருங்க, non uniform la force will be more here, force will be less here. Okay, so this attractive force will be lesser than the repulsive force. So in the force அதிகமாக இருக்கிறதால this will have a translatory motion and it will also have a rotational motion because of this resolve பண்ணும்போது we'll have sign components which are perpendicular to the center of the dipole. Okay, you'll have a net torque as well as a net force as well. Okay, இங்க வந்து no net force but net torque இருக்கு. Okay, it's more rotating but not, okay, translational force illa, rotational force irukku because both are forces தான். You have rotation force but no translation force. Paka. Okay. So the takeaway from these two diagrams is, or the takeaway from these two diagrams are, okay, in uniform electric field, a dipole will experience only translatory only rotational force. அதாவது ஓகே, அதே வந்து in non-uniform electric field, a dipole will experience both translatory as well as rotational forces. So tau net is not equal to 0, f net is not equal to 0. Okay, Okay, these are the takeaways from these two. Okay, fine. Okay, all right. Okay, we are almost halfway done through the chapter. இதுக்கப்புறம் சின்ன சின்ன டாபிக்ஸ் and then your big capacitance thing. Okay, அதோட this chapter is over. Yeah, so oh, it has repeated. Okay, okay, கொஞ்சம் எல்லாம் ரிப்பீட் ஆயிருக்கு. The same thing I wrote here, and then it has repeated again. Electric potential due to point charge. Okay, no, it's completely free. We have only YouTube la mattum we have classes. We don't have any paid batches inga, because that takes away the sole purpose of this channel. Okay, the purpose on there to educate NEET aspirants for free and prepare them for this exam. Okay, okay, all right, fine. Yeah, it got repeated again. I don't know what I did with person. All right, so now it's 8:03. I'll take a break இப்போதைக்கு. I'll be back again, guys. Almost halfway through the chapter. We have equipotential surfaces and then capacitance we will discuss. Okay, and after capacitance in series, we'll first figure out what it is, and then the capacitors in series, capacitors in parallel. Other முடிச்சுட்டு we'll solve few PYQs as people have suggested in the previous lectures as well. They comment இப்போ போட்டாங்க. I have PYQs, okay, don't worry. After solving that, we'll end this lecture. Okay, so yeah, so class resumes at 8:25 p.m. Okay, fine. See you. Hello. Hi, everyone. There aren't any paid batches. I told you already. Okay, fine. Okay. I had a really bad cough, and then my throat hurts. Ipo. You can see the difference in my voice. கொஞ்சம் replay பின்னாடி போய் பார்த்தீங்கன்னா you would know. Yeah, a really really bad one. All right. Okay. Equipotential surfaces. Still, okay. Are everyone back? இப்போ கிளாஸ் ஆரம்பிக்கலாம்ல? Okay. Where is potential difference? Oh, the date point. Okay. All right. இங்க I'll discuss potential difference. Okay. Potential difference. I told you potential at a point is different and potential difference between 2 points is different. Okay. It's related, but I'll tell you what. Say ஒரு field இருக்கு ஓகேவா? ஒரு ஃபீல்டில் லைன் ஆஃப் ஃபீல்ட் லைனில் ஐ வாண்ட் அ சார்ஜ். ஓகே, அதை வந்து இன்ஃபினிட்டிலேருந்து இந்த பாயிண்ட் கொண்டு வரேன். ஓகே, அண்ட் இன்னொரு சார்ஜ் அது இன்னொரு சார்ஜை இன்ஃபினிட்லேருந்து இந்த பாயிண்ட் கொண்டு வரேன். ஓகே, இதுக்கு W1 ஒர்க் ஆகிருக்கு, இது W2 ஒர்க் ஆகிருக்கு, விச் இஸ் நத்திங் பட் the uniform field E into Q. This is work done per unit charge. So this is the work done per force per unit charge. Sorry, this is non-uniform. Okay, non-uniform. Okay, inga potential வந்து VQ V1Q, inga V2Q இருக்கும். கரெக்டா? Because this is non-uniform. Okay, uniform வராது. When you uniform is very 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 rare. You want, if you have a charge, just imagine you're having a source for field. Okay, electric field source ஒன்று இருக்கு, and in the source இருந்து when you move away, obviously potential decreases, right? Obviously force decreases because radius, our distance from the source increases. So by r square it decreases. Okay, so இங்கே வந்து பார்த்தீங்கன்னா there is some distance between these 2 points, correct? Say this r. Okay, the potential difference between these 2 points is nothing but the work done to bring them from infinity or a difference, correct? Infinity in the point ஒரு work, infinity in the point ஒரு work is nothing but, okay, the difference between these 2 points is nothing but the work done for my charge to move from this point to this point, correct? I want to make sure you understand this. Okay, okay, pakka? Clear? Okay, obviously no one. Okay, I'll just move on. Okay, we'll have a question. I'll write a question or question. I think you'll understand it even better. okay. Charge வந்து 10⁻⁻6 coulomb, okay, 1 microcoulomb. இது வந்து ஆரிஜினில் இருக்கு 0,0ல. இந்த சார்ஜால there is potential difference everywhere. This charge is here. Because of this charge, there is potential difference everywhere. Okay, fine. We know. Obviously, it exists. Force field இருக்கும், field and potential இருக்கும். Okay, there is potential everywhere. Now we are supposed to find the potential difference between 2 points. Okay, because of this charge. Okay, let's say that these points are something trigonometry easier. Let's say root 3 comma root 3. I think this works. And this is somewhere here, and let's say root 6. Root 3 comma root 3 and root 6 comma 0. X comma y தானா? Yeah, root 6 comma 0. இந்த ரெண்டு பாயிண்ட்டுக்கும் இருக்கிற potential difference கண்டுபிடிக்கணும், which is nothing but the amount of work done to move a charge from this point to this point in the black line. Oh, no. Not that one. Right? Okay. So, in the distance, the distance is root 3 square plus root 3 square, something 3. This is nothing but root 6 distance. Okay, fine. Potential at this point is kq by r. Kq by r and 3. Inga minus kq by root 6. Okay, so it's nothing but kq into 1 by 3 minus 1 by root 6. Clear? Paka? Clear? I think I made a mistake. Root 3 plus root 3. Oh. Square under root 1 ma. So it'll be root 6 tha. So this distance is also root 6. Okay, root 6. Okay, root 6. So then the net distance will be, so it will be equal to 0. Potential difference between these 2 points will be 0. Potential difference, because the distance from the source is same. Fine, paka, clear. Okay, I made a mistake here. This is a previous year JEE main question. Okay, so look how simple it is. Dexter Doc. Anna, நீங்க என்ன காலேஜ்? மெட்ராஸ் மெடிக்கல் காலேஜ். ப்ரோ ஒர்க் டன் இல்லையா? ஓகே, ஒர்க் டன் இல்லையா? ஓகே ஓகே, ஃபைன். Equipotential surfaces. These are surfaces which have equal potential throughout their area. Okay. Throughout their area, potential is same. So you have any no other doubts, right? Okay. Anna, what are you asking? Anna, from root 6 or 0 root square எடுக்கணும்ல. No. The Pythagoras theorem, basically it's a right angle triangle inga. Correct? This is root 3. This is also root 3. So the distance from this point is root 6, okay? All right. Well, this surface is clear. They are not actual surface, but rather imaginary. Okay. See, when you have a charge, okay, a positive charge, you'll understand it well. A positive charge. இப்போ இந்த பாசிட்டிவ் சார்ஜ் சுற்றி ஒரு சர்க்கிள் ஒரு ஸ்பியர், ஓகே, ஸ்பியர் ஆஃப் ரேடியஸ் ஆர் with this positive charge being in the center, okay? So every point on the sphere, it will be the same distance of r, okay? Every point will be in the same distance. So since every point is the same distance, can I say that they'll have the exact same potential? Correct? Right? This is your equipotential surfaces. There are few applications for it, okay? For a single charge, it's nothing but circle around it, okay? Fine, pakka. But when you take a dipole, individual charges will have equipotential surfaces around it. And when you take it as a system, you won't have an equipotential surface, rather on the midline la mattum dhaan. Okay, I'll write it. Okay, one sec. Only here will the potential be, okay, inga mattum dhaan since potential is 0 here for a dipole, in the plane it's equipotential because there is no difference in potential energy wherever you go. Difference between any 2 points in this plane. இது வந்து take it as a big plane, okay? Just imagine a big square sheet. It's kept it in this way, okay? So throughout this entire plane, there won't be avlo change, and there won't be a difference between them. There won't be a potential difference between any 2 points. That's for your in the plane mattum. Okay, fine. Okay. Now notice, okay, one thing. இங்க field இப்படி இருக்கா? This plane is also equipotential. நான் அப்படி சொல்லாம முடியாதா? சொல்லுங்க. Can this plane be equipotential? No, right? Because r value changes, cos theta value irukku. So this can't be an equipotential. Okay, fine. இப்போ வந்து now just see this one, okay? இந்த பாசிட்டிவ் சார்ஜ் எடுக்கும்போது யூனிட் சார்ஜ் எடுக்கும்போது சர்க்கிள் சொன்னேன் இல்லையா? Okay, all these they have one thing in common. Circle suthi the radius is same, so throughout the entire circle the potential is same. என்ன வேற வேற கலர்ல denote பண்றேன், so it will be easy. So ஒரே கலர்னா ஒரே potential இங்க. Okay, the only similarity they have is all these surfaces field இப்படி இருக்கா. Okay, every single point on the surfaces is perpendicular to the field. Fine, okay. Now why is this important? Okay, when it's not perpendicular, okay, when it's not perpendicular, say it's not perpendicular. Okay, field இப்படி இருக்கு. Say when it's not perpendicular. Okay, won't this have on these two different points? See, இந்த ரெண்டு பாயிண்ட் எடுத்துக்கலாம், இந்த பாயிண்ட்டும் இந்த பாயிண்ட்டும். Okay, this is my field because of the charge. இந்த ரெண்டு பாயிண்ட்டுக்கும் there will be a net force, there will be a net torque as well. Okay, இங்க வந்து there will be lesser force, இங்க வந்து there will be greater force, so it will have a net force acting on it. Okay, resolve பண்ணும்போது கரெக்டா? But when you take it இப்படி an equipotential surface இப்படி, see, and also you see, you can see the distance varies, r dash. When this varies அப்பனா kq by r என்ன? This also varies, r varies, அப்ப என்ன? Potential varies. I want you to take this point into your mind right now. Okay, this is very very important. Because when your plane is not perpendicular to the field, it okay, you'll have a net electric field in the mari. Okay, when it's not perpendicular. Okay, or a component. When there is a net electric field இப்படி, okay, you have a cos component இல்லையா? அப்போ since it's from a point charge, won't this be non-uniform? Non-uniformனா over radius, over distanceக்கு வந்து field vary ஆகுமா vary ஆகாதா? Over pointக்கு potential vary ஆகுமா vary ஆகாதா? So within the surface வந்து இந்த pointக்கு there will be a potential, இந்த point there will be a different potential. Correcta? All right. When cos is 90, when the theta is 90, okay, அப்போ வந்து you won't have along the plane any field. அப்போ வந்து there won't be any change in potential. Fine, பக்கா. This is what I want you to know. அப்போ in an equipotential surface, அண்ணா please, அண்ணா JE crack பண்ணு. You could study on your own and still crack JE. Okay, it depends on how much effort you put on your own. Okay, fine. So when you have a field, okay, when you have a field acting along the surface, there won't be constant potential. Paka? Clear? Okay, this is what I want. This is the only takeaway from here. Fine. So the two takeaways from this is one, equipotential surface la charge move பண்ண வேண்டிய work இருக்கு இல்லையா, it is 0. And equipotential surfaces are perpendicular to the field always. Okay, done. All right. Now say I have to move from one equipotential surface to another equipotential surface. They are having potential energy difference, right? So anga I need some work to do. Correct? And how much is that work? This said this the distance is dr. Okay. The field is E. In the point la it will be ER1 potential. In the point it's ER2. Okay. So the work done will be equal to EdR minus EdR is equal to my work done dW. All right, Paka. Or I can write my field to be equal to minus dV by dr, where dV, okay, where dV is work done per unit charge. Okay, so yeah, it makes sense. Previous JE question, simple question. When I move from one potential surface to another surface, okay, variation of potential will be maximum when I move from one to other in a perpendicular manner or with some angle. Say I'm moving through a same distance. Okay, same distance, dr distance. Okay, this distance here, this distance here, this distance here. See, this is here. Okay, when am I having the most change in potential? Okay, இப்போ நான் அதே dr distance இந்த சின்ன angle differenceல போனேன்னா, the small angle differenceல, இந்த சின்ன angle differenceல, I am almost close to the same surface. So இங்க வந்து potential difference will be 0. இங்க வந்து there will be little more, இங்க more, here will be maximum. Okay, so when it is perpendicular move ஆகும்போது for the same distance I'll have more potential difference. Why? Equation மூலமா பார்த்தோம்னா cos theta is 0 வா? In 19 அப்போ it will be E dr மட்டும்தான். Yeah. Okay. Why does it matter here na? Because see, work done is equal to force into displacement. W is equal to Fs cos theta. Can be also be done as this. So cos theta maximum இருக்கணும். I mean cos theta 0 இருக்கணும், அப்பதான் maximum. Okay, cos theta 0 இருக்கணும். When is cos theta 0? When my field and my movement is in the same direction, or when equipotential surface க்கு நான் perpendicular இருந்தா. Okay, makes sense. Yeah, and cos theta should be maximum. If it's maximum na இது 1 இருக்கணும். 1 இருக்கணும்னா theta is nothing but force is nothing but field இந்த இப்படி போகுது, and my displacement should be in the same direction. Okay, fine. Okay, fine. All right, கொஞ்ச நேரத்தில் we'll finish it off. Electric potential energy. We are almost into the last segments. Okay, fine. Say I'm doing some work. Potential difference irukku. I'm doing some work. Where does this energy go? Where does it go? It goes to the charge. எதுக்கு போகும்? Tell me in the comments. Where will the energy go? Where will the energy go? It gets stored in the field. Okay, fine. Okay. Now see this. This is one thing. Okay, very simple. All right. I don't know why no one's replying. Yeah. Okay. No one's replying. Fine. What happens? All right. No one's replying. Fine. Electric potential energy. Let's say, imagine I have two charges. Okay. I have three charges. Okay. It's the thing. I have three charges. Okay. இப்போ வந்து individual we saw potential due to this on this. So net potential is 1. Net potential we just add it. அதே வந்து when we take it as a system, we have to take into consideration of all the possible combinations. Either these two, either end potential and either end potential. We have to take into consideration all the possible energy. All the possible combinations of charges என்னென்ன இருக்குமோ அதோட potential energy and we should add it. Okay, this is for a system of charges. The potential energy gets stored in the field. Okay, fine. Paka. It is due to the arrangement of charges and their interaction. Fine. All right. Okay. We were getting into conductors and insulators. Okay. I think I forgot to add one more topic here. This is there in every single thing. Okay. Say you have a sphere. Okay. A sphere. Okay. A sphere is charged. Positive charge கொடுத்துட்டேன். Fine. This is sphere. From gravity we know that gravitational potential of this entire sphere, or mass can be taken into consideration. I mean, mass can be considered to be concentrated at its center. Okay, similarly charge வந்து சென்டர்ல இருக்குன்னு நம்ம assume பண்ணிக்கலாம். Okay, so to any point, okay, at a distance of r1, r greater than the radius of the sphere, of the conducting sphere outside, I mean of the conducting shell. Okay, this is shell, spherical shell, because it gets distributed வெளியே. Fine. For r வெளியே it's kq by r தான். Okay, this is a conducting spherical shell. Okay, and for any point on the sphere it is kq by r radius for any point on the sphere. Okay, இதே வந்து ஒரு அந்த ஸ்பெரிக்கல் ஷெல்லுக்கு உள்ளே எடுத்தோம்னா when you take that into consideration, okay, ஷெல்லுக்குள்ளே just imagine you'll have charge distributed everywhere. ஒரு கண்டக்டர்னா வந்து when you give chargeனா எல்லாமே வந்து சர்ஃபேஸில் போய் அக்யூமுலேட் ஆகிடும். கரெக்டாக? ஓகே, ஃபைன். when ஒரு கண்டக்டிங் ஸ்பியரில் போய் இந்த மாதிரி அக்யூமுலேட் ஆகும்போது சே இதோட ஃபீல்டு இப்படி இருக்கும் அண்ட் இதோட ஃபீல்டு இப்படி இருக்கும், அண்ட் சின்ஸ் இட் வில் பி ஈக்குவலி டிஸ்ட்ரிபியூட்டட், ஸோ ஒரே மேக்னிடியூட் ஆப்போசிட் இன் டைரக்ஷன், ஸோ எனிவேர் they all will get cancelled out whenever you consider. இது வந்து இப்படி இருக்கும் ஆப்போசிட்டில், இதுக்கு இப்படி ஆப்போசிட்டில், இங்கே இந்த ஆப்போசிட்டில் ஒரு சார்ஜ் இருக்கும், everything gets cancelled out. So inside, when r is lesser than radius of sphere, inside a conducting sphere or a shell, field is 0, so potential is okay, potential is going to be kq by r da. Okay, okay, paka. There is no field, okay, but the potential is constant anga. Fine. This derivation, if you want now, I'll derive it in electrostatics in field. Okay, because I think it's not necessary inga இப்போதைக்கு. Fine. Okay, all right guys. So you know what are conductors and insulators? Do you have any doubts இப்போதைக்கு? இந்த ஃபோனில் வேறு chat ஒன்றுமே வர மாட்டேதா இல்லை it's not refreshing, I don't know, I have to refresh it often. Okay, all right. Okay, fine, paka. There aren't any. If you have any doubts, ask me in the end. Okay, I'll answer it, whatever it may be, about NEET and physics and other subjects. I'll try. Okay, conductors, you know, they have electrons which can flow with less resistance, whereas insulators are those that do not conduct electricity. Okay. Yeah. Okay. இப்போ எலக்ட்ரிக் ஃபீல்டு இப்படி இருக்குன்னு வச்சுக்கோங்களேன். எலக்ட்ரிக் ஃபீல்டு வந்து பாசிட்டிவ் டு நெகட்டிவ் டைரக்ஷனில் இருக்கும். ஓகே. அண்ட் எலக்ட்ரான்ஸோட ஃப்ளோ வில் பி டுவர்ட்ஸ் பாசிட்டிவ். தட்ஸ் ஹவு வி டேக் இட். ஓகே. ஸோ எலக்ட்ரானோட ஃப்ளோ வந்து வில் பி ஃப்ரம் இந்த மாதிரி ஆப்போசிட் வித் டைரக்ஷன் ஆஃப் ஃபீல்டு. Okay. So when you have a conductor and you're applying field in the direction there, your electrons will accumulate here and positive charges will accumulate here. Okay. And this this will have an electric field of from positive to negative. And because of this, okay, because of this the net electric field, okay, I mean there will be an external field, there will be an internal field which are in opposite directions because of this arrangement, and these two will be equal in magnitude because they are conductors. So adanal inside there will be no net field. Paka? Clear? I think when you have an insulator, okay, insulator, just no, remember, you don't have to go into molecular chemistry of all those, how it works, magnetism la pathikalam. But when you have an insulator, okay, they will form small dipoles. Okay, since ipo parungle, electrons are free in conductors, but electrons are bound to nucleus in insulators. So when you apply field in the direction there, okay, என்ன ஆகும்னா there will be a molecular கொஞ்சமா ஒரு இழுக்கும். it will be net negative charge இப்படி net positive இப்படி இருக்கும். they will be closely held, but they will form a dipole இப்போ. Okay, these dipoles will be formed, and these dipoles will also have a net field. Okay, but this field இருக்குல்லையா, this field is not equal to the magnitude of the external field. Okay, they are not equal to the magnitude, so they'll have a net electric field உள்ள. Okay, which is lesser than that of the external field. Fine. Okay, this is the only two takeaways from this chinna topic. Okay, fine. There are something called as dielectrics. They are non-conducting insulators பார்த்தோம் இல்லையா, this entire exact thing applies here. They are okay. Guys, if you're really active watching this, I will highly appreciate you to stay interactive in the live chat. Okay, yeah. Paka, okay. It's like I'm talking. Yeah, I'm still YouTube. I can't expect interaction, but still, it drives people to take a better. Okay, so yeah, when few people actually answer, I'll feel it's rewarding it's rewarding actually. Okay, it's fine. They are non-conducting substances. Yeah, they are non-conducting substances now. They may be polar இருக்கலாம், they may be non-polar இருக்கலாம். Fine. Yeah, just know this. Okay, they may be polar or non-polar, but in the end they'll form சின்ன சின்ன dipoles இந்த மாதிரி, which will form electric field opposite to the external one. Okay, so when you have a dielectric medium between two conductors, there will be a decrease in electric field. Okay. All right. Say ஒரு isolated conductor இருக்கு, ஒரு isolated conductor. Okay, இதுக்கு if I give charge, what will happen? சார்ஜஸ்லாம் வெளியே போயாகும். ஓகே, இதோட ரேடியஸ் இஸ் ஆர். will go to its surface obviously, and also it'll have some potential, okay, which is V is equal to KQ by R. Paka inside and on the surface. Fine. Okay. We know that potential of this sphere is equal to the charge. I mean, increases with the charge. Obviously, V is proportional to charge. To increase potential, I just add more charge. Okay, fine. All right. Okay. So, can I take Q by V is equal to constant? Okay, Q by V is nothing but R by K. Q by V is equal to R by K. Okay, fine. This R by K is nothing but R into 4 pi epsilon naught. This holds good for any other thing. This Q by V clear charge. For this potential difference or increase, okay, that's constant. அதாவது for amount of charge required for a unit change in increase in potential energy is same for this conductor. Okay, right? It depends upon radius அதிகமாக இருந்துச்சுன்னா I would require more charge for an increase in potential energy கொஞ்சமா, correct? And epsilon, which depends upon the material. Okay, this is my capacitance. It's basically how much charge I can hold. Okay, clear? Okay, no response. So when you see this Q by V clear, I can increase Q increase and V increase agum. So what does that mean? They are constant. Q by V is always constant. Okay, that's my capacitance. So ஒரு particular voltage கிடைக்க ஒரு particular potential difference potential difference கிடைக்க with infinity or ஒரு particular potential on the surfaceக்கு I would require some charge. அந்த சார்ஜ் எவ்வளோ கண்டுபிடிக்கிறதுக்கு I can use this capacitance thing. Okay, fine. So my Q by V denotes my capacitance of that conductor. Okay. Capacitance. Okay, let's say parallel plate capacitor. A parallel plate capacitor has two plates, okay, connected to two different terminals of the battery. Okay, fine. Paka, they'll be connected to a battery, and this will have or potential. Say this is connected to a negative terminal. Now you'll have all positive charges accumulated here, and this is connected to a positive terminal. Is all negative charges will be accumulated here. Fine. This is a conductor, and then you'll have a net electric field against the external field. Okay, fine. Okay, before getting into whatever this is, let's define this. Okay, it's nothing but Coulomb, right? Volt. So 1 farad. Capacitance is a unit on the farad, or yeah, okay. Okay, இப்போ இதோட Q by V ஓட வேல்யூ நம்ம கண்டுபிடிக்கணும். Okay, usually these capacitors, the distances are so small that so that we consider them to be infinite surfaces. Okay, to be infinite surfaces. Okay, fine. Area வந்து infinite இருக்குன்னு consider பண்ணோம் because the distance is super small. Okay, fine. Okay, ஒரு infinite surfaceக்கு கூட கம்பேர் எப்படி பண்ணலாம்னு சொல்கிறேன்னா let's just see here. இப்போ இதோட ஏரியா இருக்குது, இந்த பிளேட்டுக்கு it has some area A. Okay, and it has charge density of sigma. Okay, so this will be the charge divided by potential is nothing but V. Okay, how will I write V? How do I write V? Field into distance between them, correct? This is Q by field into distance between them, correct? What is field? What is field? KQ by R square. Okay, or I can also write it as by sigma by epsilon naught. Okay, so it's nothing but A sigma by epsilon naught into distance between them. A epsilon naught by d. This is because the distance is so small, we consider it to be an infinite plane sheet. Okay, fine. இதோட field எப்படி derive ஆச்சுன்ட்டு we'll discuss in electrostatics and field. Okay, அதில் வந்து for every individual yeah, we have normal plane and then infinite plane cylinder இருக்கு. Okay, we'll discuss. Fine. So A epsilon by D is the potential difference between them. I mean, is the capacitance. Capacitance. Fine. Okay. What if I have a dielectric in nadula? Okay. Epsilon value changes. It will become epsilon K. Fine. Before that, I want you to know one thing. Okay. இப்போ say I have இந்த மாதிரி ஒரு parallel plate capacitor. இதில் வந்து இதோட capacitance increase பண்ணும். I have to increase the capacitance. How will I increase the capacitance? Then let me know in the comments. Come on, சீக்கிரம். College went out today. Hi, நான் ரிப்ளை பண்ணுங்க. College went out today. யா போனேன். What is this question? எப்படி இன்க்ரீஸ் பண்ணுவேன்? The formula is epsilon naught A by D. Okay. இப்போ நான் capacitance increase பண்ணோன்னா I can increase the area. Area increase பண்ணலாம். Distance குறைக்கலாம். Or I can introduce a dielectric medium which will decrease the epsilon on value. Correct? Epsilon value குறைஞ்சுனா குறைச்சா எப்படி இன்க்ரீஸ் ஆகும்? epsilon value இன்க்ரீஸ் ஆகும். epsilon value இன்க்ரீஸ் ஆச்சுன்னா my capacitance value increase ஆகும். Fine. பக்கா. So usually when you see a capacitor, there are parallel plate capacitor தான். பட் எப்படி இருக்குன்னா you'll have இந்த மாதிரி ஒரு okay 2 plates attached to 2 different terminals. ஆனால் இதே plates வந்து they will be rolled okay in a cylindrical manner. And இந்த நடுவில் இருக்க gaps it is all filled with dielectric. So it will be like இந்த மாதிரி cylindrical shape with so many turns இப்படி இருக்கும். With all this space filled with dielectric. Okay, this is how a capacitor is in real life. Purpose of capacitor வந்து to store charge. அவ்வளோதான். Okay, and then whenever necessary it will give it away. A battery is different. A battery slowly it releases charge. But when a capacitor வந்து it releases charge instantaneous. Okay. Let's say this is vacuum. So இதோட permittivity of free space is epsilon naught. இதே வந்து with a medium with a dielectric constant of K இது மாதிரி வந்துச்சுன்னா so it will be K epsilon naught. Fine. K is nothing but E medium by epsilon naught. Okay, so it will be nothing but K A epsilon naught divided by D. Okay, fine. அதே வந்து when I introduce a medium not completely, so I have this. Okay, இதுக்கு distance is D. Okay, and I have thickness. I'm introducing a dielectric medium only for a thickness T மட்டும். ரிமைனிங் dt வந்து வேக்யூமாக தான் இருக்குது ஒரு ஏர். ஓகே, திஸ் இஸ் T. ரிமைனிங் D - T வந்து ஏர் தான். How will I write இப்போ? How will I apply இப்போ? I can take, consider the charge, see charge is q da, okay, but still it's epsilon naught k epsilon naught a by t plus epsilon naught a by d minus c எடுக்கலாமா? Can I write it like this? It's handwriting வந்து மோசமா இருக்கு, ஒரு நிமிஷம். Yeah, இப்படி எழுதலாமா? Just let me know in the comments. இந்த மாதிரி நான் எழுதலாமா? Can I write this? Come on, Ram Prabhu Mona. Okay, no one wants to answer. Okay, fine. It's right to some extent, but if charge is given direct, what if I have to write it in terms of q? Then it will be in terms of q எழுதணும்னா q by v எழுதணும். Okay, fine. q by v is my capacitance. Okay, this everyone knows. q by v எப்படி எழுதுவேன்? v is nothing but potential. Potential in terms of different value of k எப்படி எழுதலாம்? Epsilon naught இங்க என்ன எழுதியிருக்கோம்? It can be written as epsilon naught, I mean e, so ஒரே நிமிஷம் I am messing up here கொஞ்சமா. Sigma by epsilon naught, but sigma by k epsilon எழுதலாம் கரெக்டா? So q by sigma by k epsilon naught வந்து ஒரு பார்ட்டுக்கு ஃபார் ஒரு சின்ன டிஸ்டன்ஸ்க்கு. This is for if it were entire, and இன்னொன்றுக்கு வந்து if you can take it as sigma by just epsilon naught. இப்படி தானே இருக்கும் கரெக்டா? This is what it's supposed to be. Just understand கொஞ்சமா. It's easy, simple. All right. Yeah. இப்போ I'll write it down. Now say the potential. E will be the field okay, ரெண்டு டிஃப்ரெண்ட் ஃபீல்ட் இருக்கு. correct okay. Okay, this is field at different points. ஏன்னா because of different fields தான் வந்து there is because of reduced field, okay, between them தான் வந்து we are able to uh, introduce more charge into it. Okay, fine, that's why we are having a dielectric in the first place. If I don't have a dielectric and I keep on increasing the potential difference across them, ஒரு பாயிண்ட்ல because of the increased potential energy, increased difference in potential, the electrons just rip away, and then they will the capacitor collapses and forms a proper circuit. Fine, அது ஆகக்கூடாது, and I still need to store more charge. So what happens? Okay, I'm really sorry for whatever I wrote. It's a little wrong. So there will be a potential, normal external potential for a vacuum space, and a different potential for the thickness மட்டும். Correct? Okay, fine. This different potential is nothing but epsilon, normal potential divided by k, normal field divided by k. Decreased. Correct? Now இப்போ q by v ல if I substitute this q by v ல if I substitute this to be normal field into d minus t plus t by k. This is nothing but sigma by epsilon naught into d minus t plus t by k. பக்கா பக்கா பக்கா. ஓகே, இது நான் எப்படி எழுதலாம்? This is my E into is equal to this. Okay, fine. So when I write it in by, so sigma can be written as, okay, sigma into a is q divided by sigma by epsilon naught d minus t plus t by k. Okay, sigma cancel, epsilon naught a by d minus t plus t by k. This is my capacitance. Fine. Yeah. Okay. All right. Will Prabhanjan come for a live video? Yeah. It was supposed to be, I guess. Yeah. Sarananda kekno. Okay. In series, capacitance is nothing but 1 by C1 plus 1 by C2 plus 1 by C3. Just a minute, guys. Just a minute. There is someone at the door. Right. Sorry. See, simple. Capacitance series la irundhuchna the charge will be same. Okay, q is same. inga potential difference across the entire system is same. Okay, potential difference across the entire thing is same, just like that of resistors in parallel. No, okay, just understand. Okay, இந்த மாதிரி இருக்கும்போது, okay, first I'll finish parallel இருக்கும்போது when it's in parallel, the potential difference is same. Okay, again the signs are changed, but still potential difference same na, charge will be same. Fine. So the capacitance can be simply write as C1 plus C2 plus C3. Okay, fine. Adhe when potential difference is it's split out. Okay, inga vande charge will be Q1 plus Q2 plus Q3. Charges gets distributed. Okay, the potential difference across this is also varied. Either V1, it will be V2, it will be V3, V4. Okay, apna Q by V1 plus Q by V2 plus Q by V3 is equal to V net. This is nothing but okay, I think something's wrong here. Only since potential is okay. What? Just a minute, guys. Okay, I don't want to rush. Okay, இப்போ இங்கே வந்து you understood that since potential is across the same, the system is same, we can simply add it. கரெக்டா பக்கா clear. அதே வந்து here what happens? The potential gets yeah, the charges are same, because it's in series. Only potential changes, but in the case potential difference across the capacitors is same. Okay, when inga vande appo enna irukum, charge is nothing but Q by Q1 by V is equal to C1, Q2 by V is equal to C2, Q3 by V is equal to C3. Okay, potential is same, so we add the charges mattum. So Q1 plus Q1 by V plus Q2 by V plus Q3 by V is equal to net Q net by V. So anything by C1 plus C2 plus C3 is equal to C net. Adhe vande in the case la what happens is, in series the charge across the individual capacitor charge accumulated here are same. Okay, if it were varied na, they'd still move and then they become constant again. Okay, so it'll be equal. So inge Q charge. Only thing that varies here is the potential difference. Fine. Okay, adanal here the net capacitance, okay, will be equal to 1 by C1 plus 1 by C2 plus 1 by C3. அப்படியே opposite that of resistors. Resistor series la Q is constant. Okay, V is தப்பா இருக்கும். But since V comes மேல, R gets added straight up. Here V is in the denominator, so it's inverse. Fine. Okay, I hope this is clear. I might have confused a little, but yeah. Okay, this is what it is. Okay, fine. one more topic, energy stored, okay, in a capacitor. How do we find energy stored in a capacitor? Say there are two plates again. There are two plates again. Either charge distribution is plus sigma, either is minus sigma. Okay. Force can be written as field into charge. Okay. All right. Okay. Let's say force due to this plate on this plate is the field due to that plate into the charge on the other plate. So it's nothing but sigma by 2 epsilon naught plus into sigma into A. Correct? So the force is nothing but force is equal to Q square by A to epsilon naught. Force of one plate, force of one plate on the other. Correct? Right. Simple. Okay. Fine. I hope this is clear. Now say there's a charge which is supposed to move from here to here. Okay, this entire system, this entire sheet is moved from here to here. Fine. Okay. So then it'll be the distance between them. Correct? D. Force into displacement is nothing but my work done or energy. So Q square by A to epsilon naught into D will be the energy. Okay. This term we have seen somewhere. Inga. Q square by epsilon naught A by D is nothing but my capacitance C. So if Q square by 2C is my energy stored. Okay. This is the entire capacitance done. Yeah, I don't have time, yeah. It's already too late. But yeah, I think I solved enough questions for today's session. All right. The takeaway for these three slides are series la vande Q is constant because they're connected in the series. Okay, அப்பதான் வந்து field ஏன்னா field is constant across the entire thing. Field constant. So to have the exact same field, Q will be same. அதே வந்து parallel வந்து potential across the system is same, charge gets divided. அதனால it's C1 plus இது அப்படியே ரெசிஸ்டர்ஸ்க்கு the same concept ஆனால் it's inverted because here we know that R is equal to V by I. Okay, இங்க வந்து I is nothing but Q by T. So here charge is distributed. So individual charge Q1 by Q2 I gets distributed. So V by R இருக்கும். To add I1 plus I2 plus I3, I have to add V by R1 plus V by R2 அந்த மாதிரி. அதே இங்கே since charges are it's Q by V இங்கே Q by V னால if I want to add Q1 plus Q2 plus Q3 it's nothing but C1 plus C2 plus C3 ஏன்னா potential difference across this thing is constant. Fine. All right. Definitely, I'll try to solve more questions on this in the future classes. Okay. Yeah. So I hope this is clear. Energy stored on the capacitor. Onilla, basically you have energy. All right. You have energy, uh, which is work done to move one plate from the influence of another through a distance of d. Okay. So field is ivlo. This is field. Okay. Field of one plate. Field of one plate. This is the charge of the other plate. Okay. Why is this sigma by 2 epsilon naught? This we'll see in the electrostatics and field chapter. Okay. Fine. So this is your force. Sigma is nothing but T charge per unit area. Okay. So your force is Q square A by 2 epsilon naught. Fine. And when we write in terms of capacitance, it's Q square by 2C for a parallel plate capacitor. Okay. Fine. All right. So yeah, Idoda, I think we'll end the session and see you guys in the next lecture. I think I've completed everything. Yeah. Okay. All right. Thank you. This is a huge chapter. There is just so much in the chapter lab. I can't. I could solve 40 questions on parallel and energy stored on the capacitor எல்லாமே. Yeah. Yeah. There is just so much concept. I have to. So in one shot I'm able to cover only this much. Sometimes it makes me feel bad because எல்லாமே கவர் பண்ண முடியல but yeah, revision அப்போ studying ஒரு lecture பார்த்து to complete the entire chapter, I think this is sufficient. Yeah. Thank you so much. Aerospace T6i. Thank you.